Wait, what's generated here? Wait, remember or not? It's not electric field, it's known as a magnetic field, guys. Key thing here, you need to know that when I have a current flowing through a conductor, it will generate its magnetic field, and I can determine it using the, what hand rule is this again? Right hand thumb rule or right hand grip rule, whichever one they call it, right? Okay. So from here, this part here is your understanding. They say that there is a current carrying solenoid, which means to say the current is actually flowing in the solenoid here, right? And if you think about it, right, they even ask you which one is the magnetic field generated. A, B, and C is impossible, because if it was A, the magnetic field, the polarity should be here and here, right? This B is absolutely no idea how is it going to happen. C would be probably the polarity here and here, which is not either of the cases, guys. Your polarity when you have a current flowing through a conductor is here and here. That's why your magnetic field will go backwards here and it will go backwards here, guys. Oh my God, why does it keep disconnecting? So annoying. Okay, I need to change this already. But anyways, you understand what I'm talking about? It's because it's running low. Right hand, this one, right hand grip, right hand thumb. This thumb indicates the direction of current, guys. And these four fingers indicate the direction of the magnetic field, remember or not? For example, they will give you either X or dot. What does X means again? The current is going in or out of the paper, the current. In or out, going into the paper like this. This one is going out of the paper when it's dot. And from here, you're supposed to use the magnetic fields, right? Four fingers represent magnetic field. You can see that my four fingers are rotating in the anti-clockwise direction. This one here, my four fingers are rotating in the clockwise direction, into the paper and out of the paper. And I want to emphasize this, which we'll revisit later on. The current is the one that generates the magnetic field. When there is current flowing in the conductor, it will generate a magnetic field. Very important. This one later on we'll need it. But for now, you just need to know this. So that's why your solenoid is going to be answer donkey here. Every other answer, it doesn't make sense. Okay, everyone. Anyone wants me to clarify this question again? Anyone don't understand anything I've talked about so far? Okay, everyone. Yeah. And then you say 14. Oh, 40. Oh, okay. Wait, let's go through 35 as well, guys. So this question here, you are given a lot of information, right? You have the voltage of the battery, you have the current from the battery, because it flows like this, guys. And you have the resistor here, right? So they ask you for this, right? What's the voltage across this resistor here? To which most of the students that get this wrong, they'll use the Ohm's law formula, V equals to IR, right? Then they'll find, oh, actually this thing has 0.12 amperes of current flowing through it. Now I'll just use 0.12 multiplied by 30 and I'll get 3.6 volts, right? This 3.6 volts is consumed by this resistor here. So this guy is the one that gets the 3.6 volts. You understand? And then I want to find out how much voltage is left for this guy, How much will it be? How do I do it? Minus, it's supposed to be 6 minus the 3.6, which is supposed to give you 2.4 volts. Everyone understand? This is a very common mistake between the students. I always make them think that, what they'll do is I'll just find voltage in current times resistance, but you have to know that this current times this resistance will give voltage for this resistor, right? I need to find how much current is here, how much resistance is here, and how much voltage will be here. Or I could just straight away this one minus this one. Okay, this is a very common mistake, must know. And the last one, question 40. Okay, you're asked to calculate EMF and potential difference, right? What's the difference between EMF and potential difference again, guys?
The total amount of voltage times the drive and volume of parts by the
Very good, guys. If you recall back what I mentioned last week, guys, EMF has a formula of work done over charge, right? I said that this EMF usually is the source of the battery, source of the battery or source of the circuit, right? For example, if you look back in the notes, EMF was mentioned here, right? We talked about this, right? It is the amount of energy needed to drive 1 coulomb charge around the circuit, and you must remember this formula because occasionally it comes on and it's very rare. Means to say most of students will actually forget how to use this formula and most of them will not answer. If you can answer this, then you bump yourself up a little bit higher on the threshold. So this is a very important formula you must know. Okay. So yeah, usually it's talking about the power source in the circuit. And potential difference is measuring the difference in potential. For example, here is 3, here is 0, measure the difference will be 3 volts. Here is 3, here is 1, measure the difference is 2 volts. And here is 1, here is 0, measure the difference, it will be 1 volt. Remember? Right. That's why both of them only is using what to measure only. Voltmeter only, guys. Just voltmeter. Because both of them are measured in volts. Okay. Your body. Huh? What? You'll be surprised. I've seen people answer this. And that's when I foresee the video if I see this. Okay. Anyone else with the ABC question? Yeah. Not to proceed with here. Okay, anyways, from here, hey, we talked about this. Last week we also mentioned there's a resistance formula that relates the length and area, right? Can someone tell me what's the formula again? Resistance is dependent on the what? Who said what? I think I heard the right answer. Someone said it at the back. Is it you? It's length over area. Very good. Right. As the length increases, your resistance is obviously going to increase. As your area increases, your resistance will what? Decrease. Right. It's inversely proportional. Okay. Anyways, from here, resistance and length, they ask you what's going to happen. You're going to say directly proportional. Okay, and of course, cross-sectional area is inversely proportional. Okay, everyone. Then after that, they ask you to calculate the current in the filament. You're given this and this already. What formula should we use? What time over charge? That's wrong already, actually. What formula should we use? I equals to 230, 330 times 60. Wait, what information are we given here? What's this? This is power, right? And this is voltage. What we're looking for. So what formula should we use with these three information? Right, from here, I would have been equals to POV, right? And literally substitute the number in only. And press in your calculator, you'll get something. How much is that something? 6 units. Amperes. Make sure you write your units, guys. I've mentioned this, I think, at least 1,000 times right now. If you still lose marks for your units, you deserve it. Okay, then this question is a relatively hard question. Can I know how many of you guys attempted it? Chidan, what do you write for the last one? Very cool. Very cool. Okay, good. Guys, first and foremost, if you look at the question here, you need to understand what's going on, especially these kind of long questions. Especially these kind of long questions, you need to trace out what you're looking for exactly. If not, I see most of the time the students, they see so long question, they already lost halfway through it. And finally reading this word, right, they already forget what's happening on top already. So you need to know what you're looking for. First and foremost, it says the lamp X, lamp Y has a filament made from the same metal. Same metal means to say they have the same properties, right? So gold, copper, constant or tungsten wire, all those not affected as the filament lamp in X. The filament has keyword half the length and 1/3 the cross-sectional area, half the length and 1/3 the cross-sectional area as filament X. Okay, so if I were to draw it out, if I draw it out, this is X, right? Y is only half the length and 1/3 the cross-sectional area only, and this is Y. I mean, you gotta imagine because my drawing is a little bit shit, right? But you need to imagine what's going on. And it says it's also connected to 230 volts. 230 volts here, this guy was 230 volts also. And they ask you to find the current here, current of Y over the current of X. First and foremost, we found current of X, right? Which was 0.26 right? 0.26 amperes. Hey, pay attention, you need to look at it step by step. You will get lost here. Okay, then from here, I actually, with this and this, what else can I find? With voltage and current, what else can I find? What? Who said what? It's resistance, right? From here, I can find the resistance is equal to VOI, right? Which in this case here will be 230 divided by 0.26. Find me the resistance for this one first.
84.615.
84.16. Yeah, 6. Okay. This one, the first one is 884. Right. And with this information here, half the length and 1/3 of the area. Let's look at it from half the length first, guys. If I half the length, what will happen to the resistance? It decreased by how much? Half of, right? So from here, based on half the length itself, the 884.6, right, decreased by half already, which will give you 442.3 ohms. Just based on the length itself, guys. Everyone follow me so far? This is going to be a long step. Everyone follow. If you missed out, you better ask now. Okay. So if I know half the length already, okay, the resistance decreased by half. Well, what happens when I 1/3 the cross-sectional area? Increased by how much? All by 3.
Increased by 1/3. So
no, the area reduced to 1/3 of what is left only. So it was 9 meter cube, but right now it's 3 meters cube only. So what will happen to the resistance? 3 times. Very good. So based on the 1/3 area, 442.3 multiplied by 3 already, right? Which will give you a very big number, right? Something like this. Okay. Now with this resistance here and with this voltage, can I find the current? Find me the current and put the ratio in. That's why I say both of you guys were quite close. I think you guys somehow swapped it the other way around. Where's your calculator, by the way? I want to remind everyone to bring your calculator during the class. How much is the current? 0.173. Now you can do the ratio, right? 0.173 over the 0.26. If you did all the calculation carry forward, I would like, if you type everything in the calculator, you'll get exactly 2/3 or 0.66. If you didn't, if you rounded up your numbers, you're going to get 0.65 to 0.67 or somewhere around the lines. You guys get it? If anyone didn't get it, you better raise your hand right now, because something somewhere went wrong. Okay, you can do that also, but this is just the people understanding the current existence, how they're related. You guys correct 0.66, you answer it beyond that. What? That's fine. Good. Sorry. Oh. Don't write me right here. Okay. Well, anyone can continue. So, yeah. It's two computer and one computer. Huh? Check your working. Yeah. So I don't. It is not constant to take and say and areas is the opposite so I feel it's not like this one this one's still this one we have this one there are this one what this resistance is for this fire this resistance for this fire we just wondering the people we can find the current sort one I really need to apply the current of X. You want to offer law. This is not unexpected. This basic distance of this wire. But all the people this wire and people are really wide and the current X you found the thing actually previously that says oh my current wide and do this reason or you got it?
Yeah, I got it.
There's a limit here. I don't know. Thì mình sẽ được anh tới ngoài này từ thiếu hoặc sinh sống cái này là đến từ thiếu một nó sẽ đến tay là ao đến còn quái từ thiếu một nó sẽ đến không phải là thiếu thì sẽ được cái chưa có một cái which is there something thinking not to something something so so let's do a family stuff. Then I can already be enough to do the same line, right? Repeat. Well, you know what? Before this stuff is a remittance of the next line, right? Not right. Right. This is a line, right? So what is that in front of line? Right. What does the current one? Con vợ đó thì rất là chỉ để đá thôi về thành cái đá thì bạn từ thì bạn cái từ này gọi là có thể bỏ cái form với cái machine thì đổ accept like rather than if to the first one is rather than the blank and the form. Defining the decision how to first. The next resistance here, I can find the current. Yeah.
Hey, if I am looking up, they are playing the current here, complicated here. You're going to video on popping here. You are mean because this is popping. So yeah. Then you do this here, you can manage it to all everything. So
Okay, good. Arrow. Okay, proceed. Yeah. Guys. Hey, I want to ask, based on this graph, right? How much is the resistance of the resistor? Based on this graph, how is the resistance of the resistor? Increasing, decreasing, or stay the same? And how do I know? Okay, good. It tells me that it has stayed. This one has constant resistance, right? Because it has a constant gradient, right? What about the lamp? The lamp has increasing or decreasing resistance. And how do I know? Okay, it has what? Increasing or decreasing? Decreasing resistance. You increasing. You increasing or decreasing resistance for the lamp? Increasing. You increase. Decrease. You I think increase or decrease resistance. Huh? What? Wait, faster way. Either increase or decrease only. Huh? Decrease you increase you increase or you huh? Okay, for those who said decreasing, why? The gradient is decreasing. Okay, this is a very common answer. The gradient is decreasing. You the gradient also. You gradient also. Who else said decrease just now? Okay, why is it increasing? The current does it increase? Okay, that's a very good answer. You Not actually though. You
They're going out.
what's going on?
very slowly, the rate of
Guys, listen up. For those who say the gradient is decreasing, is the gradient representing the resistance here? What's your gradient formula? Tell me. Change in what? Yeah. Change in y over change in x, right? Change in y here is what? What over what? V over I, this is V. Oh, this is I over V, right? Okay. So I want to ask you guys, based on this formula itself, is the gradient representing resistance? No, it's not, because resistance is V over I, right? So guys, let me tell you once again, when you look at the graphs, the one that I drew for you last week, was a V versus I graph. Oh yeah, everyone, pay attention here. This is a V versus I graph. That's why when the gradient was increasing, the resistance is increasing. But this graph here, it's an I versus V graph. So the gradient is not the resistance. In fact, guys, when you see this kind of graph, right, one easy way, listen up, one easy way to tell whether it's increasing or decreasing resistance is based on this fact, right? In order for the resistance to increase, the voltage must increase, right? Right. So look at this graph here, it's tilting towards the V side already. This one for sure is increasing resistance. If it's tilting away from the V side, means to say it's actually having increasing current, which is decreasing resistance. 明白冇啊？咁多位？ So yeah, your resistance should have been constant and here should be increasing. Okay, and the potential difference is obviously 7.0 volts. Guys, I want to emphasize this answer here. It may seem like it's a very simple answer, right? What I used to commonly do is I used to write 7V, which is like a lucky gamble, guys, because like I said, right, you need how much significant figures in your answer? At least 2 and maximum 3. So when you have one single answer, it's a good habit to write 0.0. Yes. Okay. Okay, good.
Yeah.
Ignore it. Listen to me. You need to. Hey, okay, so how much is this resistance here? I think everyone should be able to do this one. Quite a straightforward one. How much? 4 ohms. Exactly. 4.0 ohms. That was the test. You passed. Okay, and the current and the energy here, wait, how much? 4.2 times 10. Definitely. 4.2 times what?
Oh. 1.8 times.
1.8.
No,
I mean the final answer. How much is the energy?
437.
437. Wait, why so different one? Times 10 to the power of. Or just 437. What? So little. Yeah, it's 437 joules. If you cannot answer, let me know. Because we'll have a problem if you can't answer these 2 questions. Okay, then this question here, which is one of the relatively hard ones. Anyone did it? Wow, that's correct. Very good. You were? What's the answer? 0.75. No, that's wrong. You were? Wrong.
I'm a genie. Yeah, still here.
It's a number.
Lisa. So, this is also one of the relatively hard question, which is testing your understanding on length and cross-sectional area for the resistance. First and foremost, we know that the original wire had 4 ohms, right? So I have the original wire, which is 4 ohms here. Okay. And then after that, I adjust the second wire. Based on this information, I know that it has 6 ohms, right? Right. Yeah. Okay. This is the second wire. Right. And I know that the second wire has half the diameter. So if here was D, right, here will be half D only. Okay, I want to ask you guys one question. Pay attention to this question. It is a very common mistake that students make. If I halve the diameter, right, what will happen to the area? If I halve the diameter, what will happen to the area? Half of the original area, is it? It's a quarter, guys. Why is it a quarter? Yeah, because there's a pi r square component here. You know, like your formula is pi r square, right? If you halve the radius or diameter, your area will actually square. Meaning to say, if let's say, for example, if let's say I had 3, yeah, it'll be 9 here. Sorry. If it's 2, it will be 4 here. If it's 3, it will be 9 here. If it's It'll be 16 here, guys. If you double up your area, or sorry, if you double up your radius, you'll get 4 times the area. If you triple up your radius, you'll get 9 times the area. And if you 4 times your radius, you'll 16 times the area. You guys know, right? Because of the square component. For those who don't trust me, right, you can draw a circle and say that the first one is 2 cm radius and the next one, which has a 4 cm radius. You'll notice that the area is going to be a multiple of 4 between them. Okay, because of the square component from the pi r square. Okay, but anyways, from here, I want to ask you one thing only, guys. The next question is, if I know that when you half the area, or if you half the diameter, the area actually 1/4, right? Then what will happen when I have 1/4 of the area? By right, the 4 ohms will become how much? If it's 1/4 the area, it'll become what? 16 ohms, right? It's supposed to become 16 ohms, right? But this 16 ohms must decrease by how much only? Because right now, after I play with the area, it's going to be the length component, right? I don't know how long is the length of the second wire, right? But I know that from 16 ohm, it became 6 ohm. So how much should I divide to become 6 ohm? 16 divided by 6. If I do 16 divided by 6, wouldn't it give me the multiple of 6 to 16? Yeah, you know what I'm trying to say. Like, if you did the multiple of 6 divided by 6, right? 16 divided by 6, this will give you 2 point something, right? Are you telling me here to here is 2 point something times the amount? No, right? So you should have done instead the 6 divided by 16, right? 6 divided by 16, which will give you 308, which will give you 0.375. Right? It means to say here to here was a multiple of 0.375, right? That's why your answer here is either going to be 0.375 of the first length, or you could even say 37% of the original length. Okay, who's confused here? You need to know this. Girls, are you confused? The boys are okay. Is anyone not okay? Good. So the girls? You know how to do this 0.375 come to be or not? I see. 终于明白吗？那大家 OK 啊 ？Okay, so your answer here is 0.375.
Wait, so what's the way to write answer? Do you write in decimal or 3/8?
Don't write fraction. That's all.
Percentage?
Percentage acceptable. Decimal also acceptable. Just don't write fraction only. Were you close? Good job.
Yeah, I agree.
The mistake I made was that I divided by 2 instead of 4.
Oh, yeah. Common mistake, guys. The diameter and radius will affect the area by a power of square.
If the radius was half, it would still be 1/4.
Yeah.
Yeah.
Radius and diameter will work the same. If you half the radius, the area will 1/4, quarter. Okay, everyone. Okay. Okay, last one before we move on. State what is meant by electric field. What's the definition of electric field again? How come when I have a positive charge here, I have electric field going out of the charge again? What's the reasoning behind it again? Replace the small what? Okay, some of them are looking at me like I've never heard of this nonsense before. Hey, I remember when I talked about the electric field chapter, I said that these electric field are imaginary, right?
You're
How did they make up this electric field? What was the reason again? Very good, guys. It was because I placed a small positive charge here and I observed where it was being forced out, right? If I place one here, it'll be forced out here. If I place one here, it'll be forced out here. If I place one here, it'll be forced out here, and so on and so on and so on, right? That's why you're supposed to say, explain what's meant by electric field. The force experienced by a small positive charge.
You're right to now I understand. You have any like still marking for those like that can see that. Yeah, obviously putting mark up for that can see. Yeah. They're really catching like it's going to be. But I don't know how you want to say. And we that. That's why
So small. Yeah. It is 0.02 amperes and energy. 120 only. Joules. Oh, it is. Sorry, I doubted you. But you were right. Well, I see there's a damn big number here, but I didn't see there was a small number here.
I don't know. That's just what it was. I thought that's other thing. But probably something like that had a lot of things.
If you're good with feng shui, right, you can make a lot of money. It's like Dr. Joey Yap.
Huh?
You guys heard of Dr. Joey Yap?
What's going on?
But there's more to the feng shui. That's kind of a funny answer, actually. I've never heard of that one before.
Also, it's like something. So you can't put your energy so it's surrounding the same virus. We died of this. Over there.
So, according to feng shui, the reason why some of the people they really like feng shui is because it helps them flow their energy better. So actually, if you think about it, right, feng shui is half superstitious, half science related, you know. And if you look at Dato Joey, he actually explains it more in terms of the science part. For example, let's say for example, today they'll say that, oh, you cannot put your aircon directly above you. This is a feng shui thing, right? Right. But why you're not supposed to put it on top is because aircons have a very high tendency to drip. So let's say, for example, if you sleep below it, you know, the aircon, when it spoils and it drips on you, your whole day is ruined, really. So feng shui is like trying to minimize the amount of bad shit that's going to happen to you. Like if you look at feng shui, right, you know, like houses that are located at T junctions, this house usually they say is bad feng shui. And you know why? I mean, last time they said that it's bad times, you very easy to die inside and all those kind of shit, right? It's the reason is because if your house is located at a T junction, right, if a car speeds here, it will build up enough speed to smash through the door and into your living room, you know. That's why they say that if you stay in a T junction house, you're very highly likely to die and all this kind of shit. So all this is feng shui, you know, it's like playing with science and logic, playing with science and emotions a little bit.
So to balance the feng shui of houses, we should increase the number of drunk drivers so that every house has an equal chance of getting a car.
Yeah. Yeah, very good. Okay, stop it. Not worry. And flip to this page, we'll move to the next chapter already, guys. Okay. There are a few symbols I would like to highlight a little bit, which you need to remember, guys. In the event you are asked to draw specific symbols, you can refer to this page as reference. First and foremost, this is relatively important. It's what we call the direct power supply, which is usually not this one. Direct power supply is from the motors, or the generators. Anyways, or even a battery, it's a direct power supply.
All of these.
No, you'll be expected to use some of it. Alternating current is relatively important also. The difference is that one is plus and minus, one has a squiggly snake in between. Okay, and then I want to say this one is important also. This is a heater, guys, which obviously generates heat. Okay, this is important. It's a fuse. You have a chapter to learn this later on. Variable resistor, thermistor, light dependent resistor, diode, and light emitting diode are important. These are basically changing resistance. The resistance will change depending on the situation, guys. But we'll learn more on that later on. Okay, you need to know the symbols, by the way. Oh, by the way, these two are just alternates. You need to say this is one alternate, this is another alternate. They're the same thing. Okay. Anyways. Yeah, this with the circle. And yeah, everything else is not so important. Bell and buzzer, you know. We have a transformer that we have a chapter on later on also, so don't worry about that. Okay, guys. This is the relatively important part. Within 20 minutes, I'll try to finish this dumb story of mine also, and hopefully help you remember how series and parallel circuit works.
Does it have to do with steering and converter?
Okay, anyways, guys, pay attention. You need to know in terms of series and parallel circuits, you need to know how the Ohm's law behave here, guys. If you look at the formula, right, it's actually just Ohm's law arranged in a different matter, right? Total voltage equals to total current times total resistance. Total voltage equals to total current times total resistance. Okay, just that in terms of series and parallel circuits, if one of them splits, right, the other one will be equal. For example, if this is the one that splits, then this will be the one that is equal. Okay, so this is the first thing you need to remember, guys. Very important. One of it splits. If the voltage splits, the current will be the same. If the current splits, the voltage will be the same. For this scenario here, the voltage is splitting, the current is the same. In this scenario, the voltage is the same, the current is splitting. Okay, so in order to understand how the series and parallel circuit works, I want to tell you one very dumb story which will hopefully entertain you enough to make you remember it. I want you to remember that in series, voltage is like a piece of cake. Okay, let's imagine today it's the twins' birthday. Okay, so the twins, they invited a few close friends to their birthday party. Okay, so this is both of them, right? And obviously they will invite their favorite physics teacher, me, right? And maybe they will invite their favorite physics teacher's brother, Gilbert. And oops, sorry, me. I mean, yes. Okay. So let's imagine today, right? Let's imagine today, I have a big piece of cake here, right? And there's only 4 of us in the birthday party. Yay. How are we going to split this cake? Quarter. Good, logically speaking, because we're all the same, right? You're human, I'm human, I'm not Tan Sri, you're not Tan Sri, you're not Sultan, whatever. We'll just separate it equally and we'll all get a quarter of the cake.
What if Gilbert was fat?
All other factors being constant, we'll get, yeah, we're all the same size also and we're all happy. Okay, we'll all get the same amount of cake. But let's say, for example, today someone very important walks in. Today, guess who this guy is? Guess who this is? He's a very important leader. Yes, it's Hitler. It's Hitler. Oh, it's Anwar lah. Okay, let's imagine it's Anwar. Probably Nazi haters, right? Let's imagine this. This is not Hitler, guys. This is not Hitler. This is Anwar. Okay. Okay, if today Anwar comes in, right, and he says, "Hey, congratulations, a happy birthday, both of you guys. I want some cake." How much cake are you going to give him? A bit? It's Hitler. I mean, it's someone very important we're talking about. Okay, we'll give them half the cake. Maybe we'll give them half the cake, right? So the new distribution will be like this, He, the very important guy with the mustache, not Hitler, guys, not Hitler, he's going to get half of the cake, and then the rest of us peasants will have to separate the cake equally into 4 parts again, right? Okay. I want you to remember this dumb story, okay? Series, voltage, he can. He's got a whole regime of people waiting to feed. Anyways, series voltage is a piece of cake, right? It will separate according to who's more important. So let's say, for example, with that information, let's say, for example, today, the first scenario happens, okay? I have 3 equal amount of resistance. No Tan Sri, no Dato, no Datin, whatever, right? I only have 9 volts here. Then obviously we're going to separate the cake equally, right? So this guy is going to get 3 volts, this guy is going to get 3 volts, and this guy is going to get 3 volts. However much battery is, however much current is supplied by the battery, let's say, for example, 1 ampere, right? This guy will get 1 ampere, this guy will get 1 ampere, and this guy will get 1 ampere because the current flows like this, right? It's not going to derail into Neverland, right? It will just go from one end to another, so all of them will get equal amount of voltage. And from here, if I have voltage and current, I can find one more thing. What's that one more thing? Resistance, which if you use normal mathematics, you'll find that it's 3 ohms, 3 ohms, and 3 ohms. Now, listen now, the individual Ohm's law formulas will all apply. V equals to IR, right? The overall Ohm's law formula will apply also. V equals to IR as in total voltage is total current multiplied by total resistance. Make sense, everyone, so far? Yes, okay. Now, someone very important comes along the fray, okay? This guy joins the party. Yay, he's like 6 ohms. And then there's only 2 of us here right now. Okay. So right now, let's say, for example, this guy gets, 9 volts. How much voltage will this guy get? And how much voltage will these two get? Six ohms will get how much voltage? Think about it logically and carefully.
4.5. What's the current?
4.5, excellent. Why? Because the total voltage is 9, right? And the total resistance here is 6, and here is another 6, right? So how much? Yeah, 2.25, and here will be 2.25.
Oh.
Shit. Which will all add them up together at the end of the day to become this 9 volts. Everyone understand this? This is very important, by the way. If you listen up, if you don't understand this and you keep quiet, right? This chapter is gone already. I can tell you, because this is as easy as you can get. If you don't get the 5 basics, you better ask now. Because later on, it won't be just resistors. There'll be thermistors here, there'll be diodes here, there'll be a switch here, there'll be something dumb along the line, which you then ask me what does the symbol represent. I'll answer you, of course, the first few times, because I don't expect you to deal from nothing. But after a while,
What about the current?
good. What about the current? How much will the current be? Think about it. Right now, if I want to find the total current here, right? What information do I need? The what resistance? Good. I need to find the total resistance, and I need to have the total voltage, right? Which, if according to my Ohm's law formula, will be I equals to V over R, right? Which will be 9 over. So you give me 0.75 amperes. This here will be 0.75 amperes. This will be 0.75, this will be 0.75, and this will be 0.75. Understand? And if you press in the calculator, 0.75 times 6 ohms will still give you 4.5 volts for the first one. Like I mentioned, the individual Ohm's law formula applies to each and every one of the circuit. The total Ohm's law formula applies to each and every one of the circuit also. Okay, everyone? Okay, very easy. Series circuits, very easy, straightforward. What about parallel circuits? Okay. Parallel circuits, a little bit different only, but it's literally the same thing. Okay, I want to ask first and foremost, just now I said that if let's say this is 9 volts lah, right? And I have 3 equal resistors here. First and foremost, how much will this guy get? How much will this guy get? And how much will this guy get? 3 ahead. No. What is it? Well, just now I said one splits, the other one will be the same, right? Then the other one will be the other one splitting, and the other one will be the same, right?
So if current is the same, then voltage should be flipped. And voltage is the same current.
Yes, correct. So how much voltage is here right now? Huh? Who? Oh, be more confident with your answer, can or not? It's 999 lah. Right. Okay, because like I mentioned, the voltage will be the same here. Is it too bright? Can you guys see? You can see the color, okay, and then let's say if there's 3 amperes flowing here, how much current will be here, how much current will be here, and how much current will be here?
1.
It'll be 1, 1, 1, right? How much current will be here, how much current will be here, and how much current will be here? 2. Yeah. Can you imagine the flow of current? The current has to flow to this intersection, split 1 and split 2, flow to this intersection, split 1 and split 1, meaning to say, if I put an ammeter here, and ammeter here, it will read 1, 2, and 3 amperes or so. Because the 1 will combine back with here to become 2, and the 2 will combine with the 1 here to become 3 again. Okay. Yeah. How much is the resistance here? 3. How much is the resistance here given 1 ampere, 1 ampere, and 1 ampere? 9 ohms, right? 9 ohm, 9 ohm, and 9 ohm. Okay. What if I have a different scenario? What if right now I have like a larger and smaller resistor? Let's say to make things easier, I have a 5 ohm and a 10 ohm. And let's say, for example, once again, I have 10 volts here.
Bigger 5%.
How much current will this guy get? How much current will this guy get? If let's say, assuming I have 3 amperes here, will this bigger guy get more current? Will this guy says yes, bigger resistor, bigger current. Yes, you equally split is definitely not the case. No. Yes. Yes. Don't know. Yes. Don't know. No. The bigger guy will get smaller amount of current. Why? Because like I mentioned, current flows the path of least resistance. Right. Remember, this word is very important. Current flows the path of least resistance. Today, if I see that this is hard, right? Current is damn smart one. It will just let 1 ampere of current flow here and 2 amperes of current to flow here, which once again will satisfy the Ohm's law formula. I times R is equals to 10. I times R is equals to 10. Understand or not, guys? It will be totally opposite of series. Series, the bigger guy will get the bigger voltage, right? In here, the bigger guy will get the smaller voltage, because once again, everything follows the Ohm's law formula. Larger resistor, larger voltage. Larger resistor, smaller current. They are inversely proportional to each other.
My question is, how do we know when the state of the current comes in?
Depending on whether it's a series or parallel circuit.
Also series, the voltage is not constant.
Yes, correct. And the other one will always be opposite of each other. Guys, I want to ask you this, based on this information I've learned here, right? Are these all lamps connected in series or parallel? Why? Why must it be parallel? It's definitely energy efficient, because first and foremost, if one of the lamp breaks, other ones can still function. The second thing is all of them will receive equal amount of voltage. All of them will receive equal amount of voltage from the power source. Right? For example, if I supply 10 volts, each and every one of the lamp will get 10 volts. Right? This is the importance for parallel circuit. Okay. Everyone, I want you to use whatever time that you have left and start copying everything down. Yay!
Hey sir. Hey sir.
While I ordered lunch.
Oh, you are. Hello. Stay away. Stay. We are the day and the day. We need to see more than the room. Say this is something. To get that releasing. Walk forward. Walk forward. Who are policemen in fast? Oh, who is that? Say, you. That is what I mean.
We did it. Oh, wait. So, they did
Yeah.
October, November.
What?
They did
Yeah.
October.
And then I tell you a secret, guys. I don't think we can help them. Oh, that's all of life.
How's
Half-life, we gotta tough it out. Because crap, man. We'll be just the world. I'm about to find the that part. Very funny. Yes. Hello. And we reveal to the sister to get them. We realize on the main thing. What is it for you? Also, the person you will find as you. It was actually a very critical play. On this foundation is the normal. Yeah. It's very. Sorry. I agree, Sam. Yes, the body. So you might eat say that you know the line. Yes. You might you want them to be alright. It's something that you want to be on the line. If they want to tap their love, that's great. Why? And it falls like 200 they want to stay, you know. Is it's actually but okay, what's the standing?
So it's 2 rounds. We're gonna just slow down. Let's just slow down. Oh, you want someone to? You see it. It's lost. Are you done with that? He grabs the ball and scroll down. It's all ground. We're going for I think. You know, our friend Dan. Oh, it's something. But it's going to be all this week. Next week, why you not? There's no.
I think there's no class next week, but I want you guys to attempt this, guys. But what do you mean this week? I mean, shut up, there's homework this week, okay? Just listen up, okay? I want you to use this information that you just drew just now. Everything from here, right? I want you to do everything starting from these 2 questions.
Oh
Alright, everyone, shut up and listen. I tell you, if next month when it comes back, I see some of you didn't do the work. I tell you, I'll kick you out of the class. I mean it, guys. If you don't do the work next month when I come back, you get out of the class next week. Okay, this 2 you must do it. This one, I think you can attempt to do it, and then everything else you also can do from here. With this done, next week we'll do one more set of exercise for the parallel and series circuit. Then we'll move on to the next chapter already. Okay, this is a very important chapter, guys. You must have your foundation properly done. Alright, guys. Okay. Yes.
Come on.
Oh. Yes, guys, for those who are done copying, that's it for today already. You can enjoy the rest of your weekend. But remember, guys, I want to see your homework next week. Oh God. Yes. Yeah, please read. Yeah, shit.
What? Upper. Back in the list of papers. Oh, yes.
And
It's not.
yeah, fuck you,
We can give you that from the
Then now.
Some vocal people that they want to steer you have seen.
Yeah.
Yeah. Oh. Yeah.
Yeah, okay. Guys, I missed out one part. Give me 1 more minute. Everyone, pay attention. Everyone, pay attention. I missed out this one very important part, which is the resistance for a parallel circuit. Okay, now the formula is given as 1 over RT, right? Equals to 1 over R1 plus 1 over R2 and so on, right? Let's say, for example, the circuit looks something like this. Okay, I have one 10 ohm resistor here and another 10 ohm resistor here. Okay, pay attention. In order for you to find the resistance here, you're supposed to do the 1 over 110 plus 1 over 10 now, which will give you 1 over 5. But this is not the final answer. because this 1/5 is only 1/RT. Okay, in order for you to find RT, you have to flip it, right? Which will give you 5/1. Means to say the total resistance from this circuit is only 5 ohms. Okay. Okay. Very important. You need to flip it, guys. Keyword, after you find this part, you need to flip it, right? And then you'll find the total resistance of 5 ohm. That's why it's much more energy saving when you connect everything in parallel, because the overall resistance is much lower. Okay, even though it's 10 and 10. If you connect 10 and 10 in series, it will be 20 ohms already, which is much higher in series.
People like a 600-volt power supply, or put it right up.
It will blow up. There's too much current flowing in the bulb already.
What if?
It will still blow up because the wire inside the bulb can't handle such a high voltage of current. Okay, everyone. Yeah. Please. Hopefully, everyone will do their work next week. Guys, no class next week. I'll see you next month. Okay. Enjoy, everyone. Goodbye.